Projectiles Type 1 landing on the plane. So in 2004 we were given a question where a particle is projected from a point on a horizontal floor of a tunnel with a maximum height of 8 meters. So we were to draw this, we have our particle is projected and the angle that it's projected with is an angle alpha and its initial speed is 20 meters per second. So we have 20 meters per second for the initial velocity, and it's projected in a tunnel with a maximum height of 8 meters. So if I underline that in the question, we have a maximum height of 8 meters. So therefore, this is the distance in the y direction. So we say SY equals 8 meters. Now we know as well that at the highest point, the velocity in the y direction is 0. Now the question wants us to find to the nearest meter the greatest range that can be attained. So the greatest range is basically SX. And it happens when the particle has landed, and therefore if it's landing on the same floor that it started from, then the displacement in the y direction will be 0 for the range. Okay, so we have to be careful to make sure that when we get our answer, it's to the nearest meter. So we have our diagram sketched with all the information on it. So we want to basically write down now our table. So our table is going to be drawn so that we have U, A, V, S and T, and we're doing that in the X and in the Y direction. So you're going to pause the video and you're going to make sure that you have checked your table, is it correct, and then come back and see are you right. So we have to remember that our initial velocity can be broken down into U cos alpha in the I direction and U sine alpha in the J direction. And if you can't remember that, well, here's U. It's projected at an angle of alpha. So if we break that down into our parallel and perpendicular components, then again, if I complete my parallelogram, I have opposite and I have adjacent. And the opposite is always U sine alpha, and the adjacent is U cos alpha. So of course this is the I direction for cos and the J direction for sine. So our U is 20, so I don't know what alpha is, so therefore U in the X direction will be 20 cos alpha, and U in the Y direction will be 20 sine alpha. We have to remember that there is no gravity in the X direction when travelling in the horizontal plane, and gravity is only acting in the Y direction. Now we have to remember that U is projected up, but yet G is in the opposite direction. It is always acting in a downward direction. So if we're taking U to be a positive direction, i.e. the upward direction is positive, then G being a vector has to be in the opposite direction, so therefore that'll be minus G. If I'm looking at V, well, we have to remember that V is equal to U plus AT. So in the X direction we have 20 cos alpha plus 0 times T, so that's just going to be 20 cos alpha. And in the Y direction, V is going to be U plus AT. S in the X direction, well, S is equal to UT plus a half AT squared. So therefore that's going to become 20 cos alpha T. And in the Y direction, it'll be 20 sine alpha T minus a half GT squared. And then we have T in the X and the Y direction. So based on the information given to us in the question, in order for us to find the greatest range, we can see that we need 20 cos alpha T. So therefore we need to know what alpha is, and we also need to know what T is, the time of flight. Now, our time of flight can be worked out by letting sy equal to 0, but we also need to find alpha. So therefore, if we look at the other piece of information given to us, we can see that sy is equal to 8 when vy is equal to 0. So if we write down greatest height occurs when vy is equal to 0, well then if we look at vy is equal to 20 sine alpha minus gt, and if I let that equal to 0, well then I can get t is equal to 20 sine alpha over g. And then I can also say, well, at this time, sy is equal to 8 meters. So in other words, when t is equal to 20 sine alpha over g, sy will be equal to 8. Now we know that sy is equal to 20 sine alpha t minus a half g t squared. So if I sub in for my time there, I have 20 sine alpha over g minus a half g, and then we have t squared, and that must equal 8. So if I multiply that out, well that gives me 20 by 20, which is 400. And then sine by sine, which is going to be sine squared alpha, and that's all over g. And then we have minus, and again 20 squared is going to be 400, and if I divide that by 2, I get minus 200 sine squared alpha, and then that's times g over g squared. So of course g goes into g squared once, and that will equal 8. So we have a lowest common denominator there, which is g, and 400 sine squared alpha minus 200 sine squared alpha gives us 200 sine squared alpha over g is equal to 8. So we want to try and get alpha here. So we have sine squared alpha is equal to 8g over 20. So therefore sine alpha will equal the square root of 8g over 20, and therefore alpha will be equal to sine inverse of the square root of 8g over 20. So therefore, if I get sine inverse of that, I can simplify that and leave it as the square root of 8g over 20, or I can say that alpha is equal to 38.76 degrees. So either are correct, either of these answers here for alpha are correct, keeping it in sine inverse form or writing it in decimal form. Okay, so now we have alpha, we basically need to work out what is our time of flight. So I can go back and I can sub in for alpha here, or I can say, well, when it lands, sy is equal to 0, and you can work out your time of flights there and sub in for alpha. But if I go back to the diagram, when we're looking at the highest point, the time to get to the highest point, this is a symmetrical graph, so therefore the time will be the same from start to finish. So basically we can work out the time of flight to reach the greatest height, and therefore the time of flight for the range will be double the time of flight for the greatest height. So I'm going to sub alpha in here to this equation, which gives me my time of flight for the greatest height. So that would be 20 sine 38.76 degrees. Or of course you can put in for sine alpha is equal to root 8g over 20. Oh, sorry. And you should get the same answer. And then divide by g. So therefore our time of flight, if I sub in there, is 1.28 seconds, because r units at the start. For velocity, we're in meters per second. So therefore the time of flight will be double this. So if I multiply 1.28 by 2, I get 2.56. So my time of flight will be equal to 2.56 for the whole start to finish. Okay, so now we know our time of flight. What we're looking for is S of x. So again, if I go back to my table there, S of x was 20 cos alpha t. So again, if you're looking at sine alpha there, it's not a very nice one to be drawing your right angle triangles there to work out cos alpha. So I'm going to just stick with subbing in for alpha for cos. So we have S of x, so greatest range. It occurs when t, our time, is equal to 2.56 seconds. So therefore we said S of x was equal to 20 cos alpha t. And therefore if I sub in for my alpha, which was 38.76 degrees, and I multiply that by my time, which was 2.56. And again, making sure your calculator's in degrees. So we have 20 times cos 38.76 times 2.56, and that gives us 39.92. And that's meters, but of course the question clearly stated correct to the nearest meter. So the answer then is 40 meters for the range. Okay, so let's have a look at the marks then. So if we go back to the start there, we were getting 5 marks for working out S of y is equal to 8 and 5 marks working out Vy is equal to 0. So for getting our time and for getting our angle was another 5. So letting the equation equal 8, working out alpha, working out our time of flight, so that's 15. Doubling the distance or working out the time of flight in full was 5 marks, and then for getting your 40, your range was 5. So you had 5, 10, 15, 20, a 25 mark question. So I just put that in at the start there. Okay.